Injection molding is a high-speed, repeatable process that quickly converts plastic materials into molded, usable parts. Unlike other manufacturing processes, this process requires very little operator intervention once in progress. Operators are only needed for process setup, troubleshooting, and part collection. The basic concept of injection molding is to take a solid plastic material, melt it into a liquid during plastification, force this liquid into a three-dimensional cavity during injection, and solidify the material into a part during cure and ejection. To begin this process cycle, cylindrical cuts of plastic material called pellets are fed into an injection molding machine through a hopper. The material then feeds into the barrel of the injection molding machine, where an injection screw rotates, conveying the material down the barrel. As the plastic material is conveyed, it is compressed against the barrel wall, which creates friction. This friction, called shear, melts the material when it rubs against another surface, allowing the material to flow. Note: a common misconception is that the barrel temperature melts the material. In actuality, it is a combination of the work of the screw rotating and forcing the resin on the hot barrel wall that melts the material. Once melted, the material flows through a component of the screw called the check ring and accumulates in front of the screw. The screw then acts as a plunger by pushing the melted resin through a melt delivery system called a runner into the core and cavity of the mold. The mold cools the material and forms a solid shape of the core and cavity. Once the part cools, the mold opens and ejects a finished part. Today, common examples of injection molding include water bottles, cell phone cases, computers, toothbrushes, automotive interior components, and hand tools.